Hi everyone, welcome to this lecture. So in this lecture, we will discuss the fundamentals of probability and the terms associated with the probability. So the first most important term associated with the probability is called random experiment. So what is random experiment? An experiment whose outcome cannot be predicted is called a random experiment. And here are the few examples of a random experiment. If we toss a coin or flip a coin, this is a random experiment. If we roll a die, this is also an example of random experiment. Similarly, if we draw a card from a deck of the cards, it is also known as random experiment. So if we take an example of a flipping a coin, we know that the two possible outcomes are head and tail. But when we flip a coin or when we toss a coin, we cannot predict in advance what is going to be the outcome. That is why the tossing of a coin is an example of random experiment. Similarly, a die has 6 sides. When we roll a die, we cannot predict in advance which side is the outcome of that experiment. Therefore, this is also an example of random experiment. Similarly, in a deck of a card, we usually have 52 cards. So if I want to draw a one card at random, I cannot predict about the card. That's why the drawing a card from a deck is also an experiment, which is known as a random experiment. On the other hand, if we know the output or the outcome of the experiment in advance, then that experiment is called deterministic experiment. There are many deterministic experiment in different areas of science. Especially if we see chemistry, we know that there is a famous experiment that if we add acid and base, we get water and salt. So in that case, we know in advance what will be the outcome. Therefore, that experiment is not a random experiment, it is a deterministic experiment. There is another term associated with the probability, and this is known as sample space. So what is the definition? The set of all possible outcome of a random experiment is called the sample space, and it is denoted by capital S. An element in S or sample space is called a sample point. Each outcome of a random experiment corresponds to a sample point. Okay, what is sample space and sample point? Now, these are the two important definitions here. So all the possible outcomes, if we close all the possible outcomes in a single set, then that set is called the sample space. When we toss a coin, we have two possible outcomes, either head or tail. So a set of head and tail is called a sample experiment for the sample space for the experiment of tossing a coin. So head is called the sample point and tail is also called the sample point. So the possible outcome in a set, so that set is called a sample space and every element in that set is called a sample point. Here we have the example of a sample space. Find the sample space for the experiment of tossing a coin once or twice. That is, if we flip or toss a single coin, or if we flip or toss a pair of a coin, then in that case, what is the sample space? So in part A of this question, there are only two possible outcomes, that is head or tail. Thus, this is the sample space, head or tail, where H and T represent head and tail respectively. On the other hand, if we flip or if we toss a pair of a coin, in that case, we have four possible outcomes. They are pairs of heads and tail. That is, the first possible outcome is that we get head on both of the coin. Then we get head on first coin and tail on the second. We get tail on the first coin and head on the second. And we get tail on the both coin. So in that case, we have four possible outcomes if we toss a pair of a coin. Here is another example. Find the sample space of rolling a single die or two dice. Two dice means a pair of a die. So the sample space of rolling a die is shown below. We know that a single die has 6 sides. So if we roll a die, either we get 1, 2, 3, 4, 5, and 6. Therefore, these 6 are the possible outcomes of rolling a single die. So if we close all the possible outcomes of rolling a single die in a set, then that set is called a sample space. So this is the sample space of rolling a single die. Now, what about rolling a pair of a die? Now, this is a tricky. and it has 36 outcomes. If you see, there are 36 outcomes in a sample space of rolling 2 dice at once or rolling a pair of die. So why it is 36? Because it is 6 times 6. There are 6 possible outcomes in a first die and there are 6 possible outcomes in a second die. Therefore, the total outcomes are 36. So this is the set of total outcome, and this is the sample space of rolling a pair of die. So look at this situation. So this is a pair. So the first possibility is that you get 1 on a first die and 1 on a second. Then you get 1 on a first and 2 on a second. And similarly, by making all the possible combination, the last is that you get 1 on the first die and 6 on the second. Then you get 2 on the first die and 1 on the second. Then 2 on both die, and we keep on increasing this and we keep on making all the possible combinations. Then the last of this row is that we get 2 on the first and 6 on the second die. Similarly, the last 6 combinations are that you get 6 on the first die, 1 on the second, 6 on the first, 2 on the second, and finally you get 6 on both die. In that cases, you get 36 outcomes in a sample space of rolling 2 dice. Then another important term is the event. So event and then probability. So what is event? Any subset of the sample space is called an event. So the simple example is that if you toss a coin, you have 2 outcomes. That is head or tail. So your sample space contains head or tail. In that case, head is a sample point and head is also called an event. Let's see further about the definition of event. So let's take an example. An experiment consists of tossing 2 dice. So you are rolling or you are tossing 2 dice. Find the sample space. Okay, the B part of this example of or this question is find the event A that the sum of the dots on the dice equals 7. Find the event B that the sum of the dots on the dice is greater than 12. Find the event C that the sum of the dots on the dice is greater than 12. And in the final part of this question or example, we have to find the probabilities of events in part B, C, and D. Let's solve this example. We have 5 parts of this example from A to E. In first part, we have to find the sample space S of an experiment which is tossing or rolling of 2 dice. So we know from a previous example that the sample space consists of 36 points. Okay, so these are the 36 possible outcomes when we roll a pair of a die. So in B part, the event A consists of 6 points. If we go back, what is event A? Event A are all those possibilities where the sum of the dots on the dice equals to 7. So out of these 36 sample points, we have only 6 points where event A exists, that is where the sum of dots equals to 7. So the first possibility is that we get 1 on the first die and 6 on the second. The second possibility is that we get 2 on the first and 5 on the second die. Similarly, 3 and 4, 4, 3, 5, 2, and 6, 1. So these are 6 points which constitute event A. So in that case, you can see that event is a subset of this big set. This is our superset, which consists of all 36 outcomes. And out of these 36 outcomes, there are only 6 events. There are only 6 events where the sum of dots is equals to 7. So that event is called event A in this example. So what is event B now? Now we have to find event B that the sum of the dots on die is greater than 10. So that's why we can say that the event is the subset of the sample space. So this event B is also the subset of a sample space S. So event B is the event for all those possible outcomes that the sum of the dots on the dice is greater than 10. So there are 3 possible outcomes. Either we get 5 on the first die and 6 on the second, or 6 on the first and 5 on the second, or we get 6 on both of the dice. In that case, the sum of the dot is greater than 10. So this is the event B, and this is also a subset of our sample space. The event C is impossible. Why it is impossible? If we go back and see the definition of event C, it is the event that the sum of the dots on dice is greater than the 12. We know that the maximum value that could be possible is 12 if we get 6 on both the die. So the event C is an impossible event. Therefore, event C is a null set. So we will represent event C with the help of a null set or an empty set. And this is also a possible event. If that is not possible, or if the event is not possible in an experiment, then we can represent that event with the help of a null set or the empty set. Now we have to find the probabilities of event A, B, and C. So here comes first the definition of the probability of an event. The probability of an event is defined by the number of sample point in an event and number of sample points in a sample space. So this is very, very easy example or easy definition to understand the probability of an event. That is the number of sample points in an event and number of sample points in sample space. So the first is the probability of event A. We know that event A was the event where we get the sum of the dots on both points should be equals to 7. So we have 6 events in that subset. So 6 divided by 36 is 1/6. Then event B has 3 events, or event B has 3 sample points. If we see here, event A has 6 points, sample points. Okay. Event B has 3 sample point. Event C has no sample point. Okay. The probability of event A will be then 6 divided by 36, because the number of sample point in a sample space is 36. Here is the number of sample point in a sample space, which is 36. Now it is very easy to find those probabilities. The probability of event A is 6 divided by 36, that is 1/6. Similarly, the probability of event B is 3/36, that is 1/12. And the probability of event C is 0, because this event is not possible in rolling a pair of die. So in this lecture, we learn about the basic definition of the probability and the important terms associated with the probability, such as random experiment, sample space, sample point, and event. So I hope you understood this basic lecture. Thanks for listening, and I will see you in the next lecture.